I am Larry Reeder, and I am Telex's subject matter expert on power systems.
So a lot of people at Telec kind of consider you the mad scientist.
Basically, yes.
Yeah, didn't you almost burn down one of our buildings before?
I came close, yes.
Yeah, testing batteries.
Testing batteries, that's right.
So what do we got
And we're
behind-
still testing batteries.
So I'm not an expert. So what do we know? What do you know about batteries? What can you tell us for the layman out there?
Well, we do a lot of different evaluations. Everything that we're doing today is slanted towards advanced batteries and advanced alternative energy, and the replacement of lead acid as the basic technology that's been around for a lot of years, with lithium iron phosphate is the battery that we're doing at the moment. We've also got lithium polymer and gelled electrolyte roll batteries in here and under test at the same time.
So essentially, this is old school,
Old school.
and this is new school.
This is, oh my God, coming school.
And so this is what's in the network currently,
Correct.
and that's kind of what everybody buys. But everybody's going this way. The Leaf, my iPhone, does my iPhone have that battery?
Your iPhone uses this technology.
Okay, very cool.
Correct.
So I keep hearing clicking behind us. What's going on?
Oh, this battery's under test, and what we're doing is recording a lot of data, and what you hear the clicking for is the data logger that is logging all of the data coming from all these little wires we've got stretched all over here. In this particular case, what we're doing is developing a charge algorithm to balance the battery, to balance all the cells in this battery.
So mathematics.
It's deriving what sequence, cause and effect, that it takes to control this battery whenever it's time to recharge it and balance it out.
So you design the algorithm, you get it all dialed. What's the end benefit for the customer then? What's the goal here?
In this case, it's keeping all of these cells at the right voltages means if I let them get too far out of whack, I'll have a low voltage cell, and whenever it reaches its low voltage, it shuts the whole battery off.
So this
So-
is going to keep the system running
Longer,
forever.
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 Right.
Well, for the life of the battery.
For however long the battery lasts, exactly.
Okay.
So, and once we figured all that out and we know exactly how we want it to happen algorithm-wise, then we turn that into software that goes into a processor that actually controls the charging of the battery. The software, the processor's in a control unit. This is a prototype of the control unit, but this has got processors in it, it's got the control interfaces in it. This is the actual active device piece of it that actually switches the batteries on and off of the various charge buses or charge systems. They got it. So this is all of the, once it's finished, these boxes probably turn into something not much bigger than your iPhone, but for prototypes, that's what all this is. And these run all the various batteries in the different test cells that we've got. We're trying to find, as we go into alternative energy, the battery becomes paramount. You remember, the battery we use today, lead acid and telecommunication application, is a standby battery. The old school battery. It just sits there and waits for commercial power to go out. It's the only time it operates. When we go to alternative energy or off-grid, any of those technologies, the battery is active all the time. It's either being charged or being discharged constantly. Those are a different technology in lithium batteries. Those are lithium polymer batteries, which is a different material than is used in a lithium iron battery, obviously.
Yep.
So these are an older technology, if you will, in lithium. That's basically a newer. That's more of a high performance, and this is more of an old school, whatever kind of a thing.
So we're staying up
in
with
the
times.
lithium, but we're trying to balance all the technologies to make sure that the decisions we make are the right ones. And part of our goal is long life, high temperature, harsh duty battery, and so we're having to really kind of put a lot of pressure on the manufacturers to give us what we want in the form factors and methods we want them. So that's why we've got all different kinds of things around here, is evaluations to make sure what we get is what we want and what we need. We've done a couple things here. One is we've built a lab mock-up of an actual cell site. So we've got Nokia radios, which don't work, but you can see, yeah, these are the Nokia radios. You can see where I can put dummy terminators on them, so I can actually fire those up. I can't put the antennas up, the FCC would arrest us. But I can put terminators on them, and we can fire them up so that I can have the radio loads. But we've actually done that in doing some tests for major clients for configuration and whether or not we can cool it under the actual radio loads, that sort of thing.
So you heat it
So,
up
yep.
with the radio loads, and
Right.
you test it before the customer ever takes it out to their site.
Right. So we know what it's going to do in the cabinet and what our configuration that we're configuring for.
And you can work with whatever batteries we have in our network.
Absolutely.
Okay, I've
Absolutely.
seen a solution.
As you can see, these down here are
These red ones?
the red ones are a particular brand and type of battery that's lead acid, but it's used in the high temperature type environment. So we get a little more temperature variance out of those guys, and we've got a major customer that we evaluated those, recommended them, and they use them. We've got the power plant, DC power plant. We've got heat exchanger in the door and thermoelectric coolers in the bottom of the door for the batteries, to keep the batteries cool.
Okay.
And this is the equipment side of the enclosure. So that takes care of the box, and this sets out on the cell sites, and we've got literally hundreds and hundreds of these that are deployed. Then for the alternative energy side of it, we have brought in solar. We've got 48 volts worth of a solar system up here, and we actually run it off a metal halide lighting system, and also wind turbines. All of it connects back to this cabinet, so now we can evaluate and figure out what we want to do as far as switching, how this reacts with that, and fit them all together and make them work homogeneously together as a system. And that's what all this is about, is the experimentation, discovery, and development of advanced power. Starting over here, you can see I've got two big rheostats, controllers here, so I can control the speed of the turbines. And over here on this bay, I have the controllers. This is the two turbine controllers. This is the solar controller that's tied into my power plant. So all of this equipment, including this rack, that rack, the whole bit, all connects to the same bus as the rectifiers do. So the batteries are another load on it, just like the radios are down in that cabinet, right?
Getting the flow.
So all of that stuff connects together, which is what we're trying to achieve here, is an uninterruptible source of power. So if I've got solar, I can use it. If I've got wind, I can use it. If I have the two of them together, I can proportionally use the power available from both of them. If I don't have enough power in the solar and wind, or no power in the solar and wind, I still have AC in my rectifiers. So I'm back to a conventional run rate. So that's what all this stuff does. Now when I turn these on, they're going to get a little noisy. We'll turn both of them on, and I'll just kind of throttle them up slowly. So there's maybe 4 or 5 mile an hour wind.
So that's a 4 or 5 mile an hour wind?
Yeah, about that. It's about that much. So now, if I have a gust,
Wow.
that sort of thing. So now if I apply those to the bus, you can see it stalled.
Yep.
I didn't have enough wind to keep it going. So right now, the whole mess, everything you see in this cabinet, including the heat exchangers, all the lights, TEs, everything is running off of those two turbines and that solar panel. And we're recharging. We've got 3 strings of batteries online, so I'm recharging 3 sets of batteries now. And if your battery's big enough, it'll run whenever it doesn't meet your need. You just run on the battery. You don't need to use any commercial electricity. So you could do a complete off-grid. And you don't have to have 8 hours of sun a day and 20 hours of wind a day. The difference is the battery. However much sun and wind I don't have, I replace it with battery. Now a lot of people say, oh my God, that's expensive, but some of the new technology we're working with, we're up to almost 10 years in life expectancy with a maintenance factor approaching 0. All we need to know is what your loads are. We do a study based on the location, so we know what to expect as far as sun, wind, the environmental impacts of powering one of these guys. And the rest of it is just engineering calculation.